Everyone, welcome to the lesson or this video on the first lesson in the Human Body Part 1 scheme of work. This scheme is, it's the first biology unit in Year 7 that we cover, so it's kind of an introduction to the idea of cells and things like that. But we really start at a kind of organism level and work our way down, which is not always the way this is taught, especially in Year 7. And the reason for doing that is because we want to make it much more concrete to those Year 7 students and start with kind of the way they think about the world. And actually, the case study that we're going to look at today, we're going to look at Galen's view of what was going on inside the body versus William Harvey's view. But it's worth remembering that to Year 7s, actually what's happening underneath the skin is probably a bit of a mystery. They don't have these mental models that we have about how everything is moving around inside. And the key idea that we want to get across throughout this scheme of work, because we're going to cover lots of what comes up in kind of organisation at GCSE, the key idea here is the double circulatory system. That really shows how the heart, the lungs, the digestive system, the blood vessels, all of that stuff, how it all fits together. And that's why, in terms of biology, really Harvey's discovery of the circulation of the blood is the first great biological discovery in the modern scientific era. And that's what we're going to focus on today. So before Harvey, the kind of authority on what was going on inside the body was a chap called Galen. I can't remember when Galen was from. I think he was kind of late Roman era, but I would have to look that up. But anyway, he wrote various books on the human body, and he was widely considered as the authority. That's just how the body works. And to us now, it looks kind of mad, the things that he talks about. But it's worth showing this to students to say, to really give a compare and contrast and show why Harvey's, the modern view of what's going on inside the body, is just so much more powerful and actually explains a lot more and fits a lot more with the evidence. This is a really nice opportunity to, again, show some of that disciplinary knowledge in science. So if we draw, we're just going to draw the top half of the body here. Show what Galen thought was going on inside a body. And it's worth emphasizing, this is something that we'll come back to throughout this scheme of work. Back in Roman times, the ancients, they already knew that there's really two ways that we put things into our body. One way is by eating stuff. So clearly, there's something important that we have to take into account there. Another way is by breathing. So somehow eating and breathing are really, really important, and that's somehow nourishing our body and keeping us alive. And it's interesting to see how Galen explained that and how that differs to how we think about it now. Because what Galen thought is that, well, okay, we eat stuff, and through anatomy and stuff like that, he'd worked out that the liver was connected to the digestive system. And he thought the liver was the really, really important point. I'm just going to draw a simple liver like this, kind of triangle. He thought that was where everything began. So he thought, if that's the liver, we can label that here. And I always, rather than do a kind of schematic version, I tend to draw a human body here just to give students a sense of roughly where everything is. We'll go into this in more detail later in the scheme. This is just a really quick sketch at this point to give them an overall picture. So we thought blood originated in the liver. And this was effectively pumping it around the body. The liver was the organ that did a lot of that work. And he thought that from the liver, blood was sent all over the body, and that's to everywhere, through the veins. So we could add here veins like this. So this is step one of Galen's scheme. What he thought was going on was that blood originated in the liver. So we ate our food. He talked about what's called natural spirit. So he said the natural spirit that just keeps everything nourished and keeps everything going, keeps all the tissues built and stuff like that. That comes from food. goes to the liver, and then that's sent around the body. And then the next stage here, that it came to the heart. Now I'm going to draw a really simple heart here, because I'm just doing a very simple diagram. And he thought that from the veins, that all the veins, they took blood back into the left ventricle. Now, again, I wouldn't worry too much about left and right ventricle and that whole thing of, you know, imagine it's on the page and all that stuff. We're going to do a proper lesson on the heart later. So if you want to just say it goes to one ventricle, that's absolutely fine at this stage. But through the veins, it came to one of these ventricles. And then Galen had this idea that inside the heart, what happens is it moves from one ventricle to the other, from the left to the right ventricle, like that. And in the right ventricle, what happens is it kind of mixes with the air, and we get this kind of spark here like this. It gains what's called vital spirit. So it mixes with this stuff we breathe. So again, we're getting you don't need to go on about the spirits too much, but it gets the natural spirit from what we eat. Then inside the heart, it mixes with the air, it fuses, and it gets this now vital spirit, which that allows us to move and all that stuff. So he kind of saw that there was a link between movement, exercise, and breathing. So he explained that in terms of vital spirit. And the next thing he said was, well, from the heart, then this vital spirit is again sent all around the body, but this time through the arteries. I should label this as the heart. Going through the arteries. So again, he realized that blood is going into the heart through the veins, and it's going out of the heart through the arteries. Notice in his cycle it only goes through the heart once. That's the difference with Harvey's. But anyway, this is step 2, what's going on in the heart. Now, what Galen thought was that the final stopping post, let's say, the final thing that's happening is that through the arteries, the blood ends up in the brain. And there, and I'm not sure exactly what the mechanism was here, but Galen I've not read Galen in the original, I must confess. But what Galen thought was happening was, in here, it picked up these, what's called animal spirits. And these are the things that allow us to control our movements, not just move automatically, but actually control them. And he thought the blood went into the brain, picked up these animal spirits somehow, and then these were kind of diffused through the body, through the veins, and allowed us to consciously move ourselves in that way. So that was the third stage. So into there, and then out again through the nerves. So we could kind of go, I don't know how we're going to draw this, but then out again through the nerves like this. Nerves here, like that. And again, you can choose how much detail you want to go into here with your students, but what's important here is that what we're showing them is that there's another model, another way of thinking about what's going on. They notice the same things as we could all notice now, that breathing and eating are important. The way they explained that, the model that they used, was very different to ours. And what we want to show them is why this model doesn't quite work, whereas the modern model does. So this is our guess, effectively, and I can add a label there. This is what Galen guessed was happening. If we go to the next stage and we deduce, what would we expect to happen? Well, there's really two things here, and I can move up like that. So one thing that you would expect to find when you did a dissection, because blood is moving from the left to the right ventricle inside the heart, what you would expect to find, on the one hand, is that if you were to have a look inside the heart, and again I'm doing a very simplified diagram, but if you were to look inside the heart and you were to zoom in on one of these walls, well, what Galen's theory would suggest is that inside these walls here, you should have these little holes. I think people call them interventricular pores, something like that. Anyway, little holes for blood to pass through. And it's really interesting because before Harvey, there were some famous people who did anatomy, who really did it to this incredible level of precision, nothing that the ancients had ever achieved. And try as they might, they could not find these holes. However hard they looked, it was a solid wall in the middle of the heart. They couldn't find them. And you may well do a heart dissection. This is the kind of thing you can draw students' attention to. That is a really solid wall in between the two ventricles. Nothing is getting through it. So this is one reason why eventually Harvey realised we were going to have to throw out Galen's model, is because try as they might, they couldn't find these little holes to allow blood to go from one ventricle to the other. The other one, which I think is worth sharing with students, it's a bit more complicated, so you can choose, depending on your group, whether you want to go into this. But Harvey also did some maths, and he said, well, okay, if the average person, I don't know whether this is the exact calculation he did, I can't remember off the top of my head, probably not in grams, because this was in the 1600s, but anyway, he said, well, okay, if the heart beats at 70 beats per minute, and on average, I think it's about 60 grams, so we'll do it in kilograms just because it makes the comparison easier later on. But on average, if the left ventricle has, sorry, the right ventricle, yeah, one of the two, I can't remember, left ventricle. If the left ventricle has 60 grams of blood in at any one time, well, you can show students under your calculator, okay, so what the heart is doing is sending around this blood that's being produced by the liver. So you've got 60 grams being pumped every time. So that happens 70 times every minute. So in a minute, sorry, that should be 0.06. Okay, so in a minute, every minute you're sending 4.2 kilos of blood around the body. Okay, so how much are you doing in an hour? If we times that by 60. 252 kilos. Okay, so that's about kind of 3 or 4 grown adults worth of weight. That's a lot of blood that the body's making. So how much would that be in a day? Okay, 6,000 kilos a day of blood. That sounds a little bit crazy, doesn't it? And again, it's quite a subtle point. 6,000 kilos of blood per day. But this is what Harvey realised, is that there's no way we could eat enough food to produce that much blood to diffuse around the body. This blood can't be being generated all the time and sent around. It must just be coming around again and again and again and again. And it's a really interesting example. We'll see this later when we study the phlogiston theory, for example, in chemistry. But scientists didn't really take these quantitative measurements that seriously, or actually we could say until they took these quantitative measurements seriously, they weren't really scientists. And this is the genius of Harvey, is that he realised that you have to look at the numbers and say it makes no sense. There's no way we could produce that much blood. That's just madness. Actually, it must be the same blood that just goes round and round and round and round. And that was the genius. So he said this is another reason it wouldn't work. He also noticed the valves and the fact that we've only got valves in the veins, not the arteries, and that kind of wouldn't work because in Galen's model you should have valves in both. I think that's a bit of a subtle point, so maybe we'll leave that for now. But the point is here, because when we checked both of these things, just, well, we either couldn't find them or it didn't really make sense. What Harvey did was come up with a new model. So let's look at Harvey's model now. And again, this is where we're introducing what is the core concept that ties together everything in this scheme of work. And we're not going to go into loads and loads of detail now. We can just give a really simplified picture. But effectively what we want to show students, it's a bit wider this time. This. What Harvey realised was that what's going on is this. If we have the heart here, he realised that the heart is doing two things. So firstly, in fact, let's do this first. Firstly, it goes to the lungs. So it goes from the heart to the lungs, outwards like this. We can draw an arrow to show this is happening. It goes to the lungs. And that goes out through an artery. So you might want to put artery here, outwards from the heart. And then it comes back. You realise that blood must come back into the heart through the vein. Now we don't need to talk about pulmonary at this stage, we'll come back to that later, just giving an overall picture at this stage. He then realised that it goes out of the heart again. So this time it goes out of the heart again, and that's where it goes all over the human body when it leaves the heart this second time. So it goes to all the different parts of the body, and again it goes out through arteries. And then all of that blood eventually, Harvey realised, must come back into the heart again on the other side, and that comes in back through a vein, or the veins. Now this picture is a little bit hard to make sense of, but I think it's helpful to start with something a bit more concrete and then go to a kind of abstract schematic version. So what we can do is show students that another way of representing Harvey's guess was as follows: that blood starts at the heart. In fact, I might come down here. Blood starts at the heart, like this, and then it goes to the lungs. And again, this is a really simplified version at this stage. We're going to go into more detail in later lessons. But it then goes to the lungs. So we can show it's coming out here like this. It then goes from the lungs back to the heart, out from the heart again to the body. And finally, it makes its way back from the body to the heart. And what you could do, just to make it clearer to students, is label this. So it goes out through the arteries and comes back into the heart through the veins. It then goes, let's finish that off, arteries. It then goes out back to the body again through arteries and back to the heart again. So that gives them a really simple picture of what's going on. And this is the model that we're introducing in this lesson, and this may well be the first time we've seen it. And again, this is one of those things where, as experts, this is just so obvious. We completely think in these terms already. But for our students, this picture is the one key concept we want to spend the whole of the rest of the scheme getting across. This is not easy to understand. It's quite counterintuitive. So we need to keep coming back to this picture and keep reinforcing it. And every lesson that we'll do, we'll come back to this picture and we'll say, look, here's how it all fits together. Now let's zoom in, let's say on the heart, and then we do the lesson on the ventricles and so on. And then let's come out and look at the big picture. How does it all fit together? Next, let's zoom in, see what's happening in the lungs, so on and so forth. We can do the same with the veins, with the arteries and so on. But this is the big picture that then every lesson is going to reinforce. And in terms of our guess, deduce, check model, what we'll do really is the deduce part. What would we expect to happen from Harvey's model? Well, that's kind of what each lesson will be aiming to address. Yeah, I think I'll leave it there. We will. Oh, the other thing I was going to say, the other key concept that we're going to need to get across here that we haven't introduced in this lesson is respiration. So there will be more on respiration, but that's another idea that we need to get across, because that's obviously going to be really important in terms of seeing why it goes to the lungs and why it goes to the body. So this lesson is about just giving the overall picture. The why is going to come when we introduce this concept of respiration. Anyway, that's a long video. I hope that was useful.